Today we are going to start the weekly webinars. So we are going to do each week a webinar for a couple of product lines, and today I'm going to give a webinar about CO2. So welcome everybody. What we are going to do today, I'm going to give the presentation, and it's going to take an hour, so I will try to do it in 50 minutes, and then we will have at the end a 10-minute question and answer session. So what you can do is in the live event, you have a question and answer box. So if you have any questions, you can write them there, and we will try to answer them. Can't promise you we will have time to answer them all, but we will try. But anyhow, if you still have any questions not answered, you can always email us. So I am going to start now with the presentation. Welcome, and I hope you will enjoy. What I'm going to talk about today is, as I say, the CO2 and multi-gas incubators. So we are going to go through the product line overview, the optimum cell growth, how you can do that with stable control parameters, protection of cell culture. So we are going to talk in this part about all the prevention and intervention techniques we have, and how you can increase the work efficiency using our incubator, so the intuitive usability and ease of use. Starting with the product line, this is our whole product line of CO2 and multi-gas incubators. So we are starting with the 50-liter models, the MCO 5AC and the MCO 5M, and the M stands for multi-gas. And then we have the 170-liter models. As you can see, they are now in white. We will have also a new version of the 50-liter models coming up, but it's delayed and we still don't know, but hopefully by the end of this year. So for the 170 models, we have the 170 AC, the 170 AIC. We have also 170M for multi-gas and the 170 AICB. So you have the option also for dry heat sterilization. We are going to talk about all these options during our presentation, but this is only an overview so you can see. We have, by the way, for the MCO 170 AICD, we still have a couple of incubators still in the gray color. So if you might order them soon, you might still get the gray one. And we have the 230L model, so the 200 liters, and we have the biggest model, so the MCO 80IC for 500 liters. We are going to go through all these incubator and specs. So you don't need to know them all by heart, as everything is stated in the brochures. A couple of these incubators are medical device, and that also complies to some of our -80 freezers and the plasma freezers and blood storage banks. So you can get the certification and we have them, so just for you to know. We are now going to go through the optimum cell growth, so stable control of parameters. So I'm going to go through all of these parameters that we have and the techniques to control them. So what you want to reach with a CO2 incubator actually is to grow your cells for research or either production the same way they grow in the mammalian body. So, and therefore you need to control the CO2, the oxygen, and the temperature and the relative humidity. So this is what you all need for your cells to mimic the conditions in vivo. So cell culture incubator, so what you need to know. So the mammalian body consists of different type of cells. What you actually do is you take a biopsy and you extract the cells you want from the body, and you isolate the cells, you sort your cells, and then you would like to culture them in order to grow the required or the wanted cells in medium. So your cells will then grow and multiply, and the more they multiply, the better you can see your cells, because sometimes you have some tissue cells and you want to grow them because cells are very small. So while growing, you have to check your cells' vital signs to see if they are growing well, if there is something wrong. So this vital cell, all these the vital signs are, as I say, temperature. You need to have the optimal temperature for your cells to grow to mimic the temperature in your body, which is mostly 37 degrees. The CO2, so to control the pH of your cell culture media. So it's the CO2 between 4 and 7, which is 5% is the optimum one. You have some cells that need another CO2 percentage, but it's up to the researchers to know that what they want, and you can set up our incubators if you need to, if you want another percentage of CO2. The humidity, you want to control the humidity level, and mostly it is 90 to 95% optimum. 95% the optimum humidity, the relative humidity what you want your cells to grow in, and the oxygen level in case of a multi-gas incubator. These parameters, you need to have them, but you also want to control that they are at the right level, so your cells will not be damaged or stressed out. So we have a couple of technologies to control the growth parameters inside our incubators, and some parameters also, or some technologies to help avoid contamination. I'm going to start with the technologies to control the growth parameters, and later on we are going to talk about technologies to help avoid contamination. So first, to control CO2, you need a CO2 sensor, and there are two types of CO2 sensors which are available. There is an infrared sensor, and the infrared sensor measures the CO2 concentrations of two different wavelengths at 4.0 and at 4.3, and within the absorption spectrum of CO2 is 4.3 the optimum, and 4.0 is a stable line. And how it works is that the more CO2 in the incubator, the more molecules are within the incubator. So you're constantly measuring that. So the CO2 manages the pH value of the medium, and that's how the pH value will be controlled. So if you have less CO2 in the incubator, that means that your pH will be basic and the medium is then red. So and then you may add, that is actually an indicator. So generally in cell culture, medium phenol red is used as an indicator, and which is how this medium is supplemented with phenol red, and a yellow color of the medium indicates that the pH is too low, acidic, and that means that there is something wrong with your medium, or there is a contamination, or mostly you just have to refresh your medium to get the correct physiological pH value. This is so we have this sensor, as I said, and you can check then your parameters, your CO2 parameters with the CO2 sensor. So as I said, the CO2 molecules absorb the infrared light, so the infrared sensor sends an infrared light out, and the CO2 molecules will absorb the infrared light, and there is a filter in between, and there is a sensor, and the more molecules will be absorbed, the less signal is sent, and the higher the CO2 concentration is available in the incubator. So this is about the PID controlled dual R CO2 sensor. Yes, so what is important is that you quickly go back to the optimum CO2 level when you open the door, because when you open the door of your incubator and you then close it, then your CO2 value will be shifted, and you want to get your incubator back to the optimum CO2 level, so you will not get a basic medium, but also that you will not get an overshoot, because if you reach the 6% CO2, your medium will be acid, and that if you're below the medium, so that you don't want to have that. So you have to want to have your medium quickly possibly be around 5%, and as you can see in the graph, ours will get, so when you open and close the door, you will get back to the 5% of CO2 within 5 minutes, actually mostly within 3 minutes, which is very fast, way faster than our competitors, if you can see in the graph. So the blue line is the competitive model with a TC sensor, and ours is the red line. Microprocessor PID control. So the system is controlled with PID, which means the microprocessor proportional integral derivative. So the basic idea behind the PID controller is to read a sensor, then compute the desired actuator output by calculating proportional, integral, and derivative responses, and summing those three components to compute the output. So what happens in practice, after you open the door and close it, the valve will open and it will fill the incubator till around 4.5% very quickly, and then the valve will be closed. And if you are standing next to the incubator, you will hear very softly a click, click, and that's when some CO2 is added. So in this way, the way the CO2 is added is very stable, so without any overshoot, and also being quickly back to the optimum CO2 level. As you can see in the graphs, also with temperature as with the CO2 level, they are both controlled with a microprocessor PID. So the advantages is it has a fast recovery, feed-forward control, no overshoots, and very stable conditions, which gives more predictable growth conditions. So control of CO2 thermal conductivity sensor. So the thermal conductivity sensor measures the difference in thermal conductivity of the closed and open cell, and it depends on the relative humidity, because the more relative humidity, the better the electricity runs. So with the TCE sensor, it's really slow, and with the infrared sensor, which is not dependent on relative humidity, it's faster. So if you're opening the door once an hour or once in, then it's okay. But most of the labs and working with cell culture, that doesn't happen. They open the incubator most often in an hour, or they have more people using that incubator, and they have to open that. So, but using our incubator, it's not a problem. So if you are doing cell culture and opening the door several times, then you can definitely sell this incubator to your customers. So control of the O2 for only for multi-gas incubator, we have also oxygen. So you have different level of oxygen actually in your body with different terms. So as you can see in the picture, normoxia is the term most often used to describe atmospheric level of oxygen. This range is generally resides between the 20 to 21% of oxygen, and oxygen level can vary depending on the altitude, as well as how much CO2 is being utilized within the system. So, and you have then physiological oxygen level, which tends to be between the 7 and 3%, or most commonly 5%. Then you have the lower one, which is hypoxic, which is below 2%. The same. So in the multi-gas incubators lower oxygen levels to bring cultured cells to oxygen levels that precisely mimic the tissue from which a particular cell is derived. And you can recheck with our incubator. So our O2 or oxygen is controlled with a PAT zirconia sensor, and our sensor is actually very expensive, but our sensor is very stable, and it doesn't include moving parts, and uses zirconia to measure oxygen. There are some competitors who also have zirconia in their sensor, but it's not the same as ours, because our competitors use their zirconia in their sensor, but by the time all the zirconia is consumed, you need to replace it. Whereas in our sensor, the zirconia is stick to a plate, and this plate will be warmed up to 400 degrees Celsius, and this makes the oxygen molecule to pass through the plate. So an electric current takes place, and the voltage of this electric current will be measured. So the more oxygen molecules, the more electric current will pass, and this is how the measurement is done. So, but it works as a catalyst, so the zirconia is not being used, but it stays inside. So it's a very stable sensor. What might go wrong is when some people want to clean the sensor, and use cleaning detergent inside the sensor, and then you will get some moisture. And if you have that moisture to 400 degrees Celsius on the plate, which will get, then this will explode, and then the sensor will be damaged, and in this case you have to replace the sensor, which is very expensive. So the Advantages of the PID zirconia sensor: fast recovery, feed-forward control, no overshoot, maintenance free as you don't need to refill it with zirconia. It has a lifespan of more than 10 years, and it measures between 1 and 80% and 22 and 80% O2 with one sensor, so you don't need to have doubles, and does not require periodic calibration and has a long lifespan. So this is about the zirconia sensor, the oxygen sensor, and the CO2. The control parameters of temperature. So we have a direct heat air jacket system. So the direct heating of interior walls promotes faster recovery times. So you have the red dots in the front view. What you have are independent base heater, and then you have the air, which are the waves, which is the air jacket, and you have the heater elements bonded directly to interior walls, and you have outside extruded polystyrene or melamine resin foam. So how it actually works is like a thermocam. From inside it's warm and it's cooled from outside. So a gentle fan circulation maintains the uniform heating, so delivering regular temperature to all cultures regardless of their place. So you have always the same temperature in the whole incubator. So the chamber is completely foamed with melamine, so there is no air between the chamber and the insulation due to heat sterilization. So there are also some competitors. We have water jacketed and the water jacketed system. So they are very heavy because you have to put around 300-liter water in it. It is stable, but still. The temperature, full parameters of temperature. So to control this direct heat air jacket system, so it ensures highly reactive temperature control in response to door opening. So every time you open the door and close it, direct heat is provided by 3 dependent heating sources. So surrounding the chamber, and in the top and rear wall in the chamber base, and in the outer door. So all of these are controlled by the microprocessor. So the outer door heater warms the inner glass door relative to ambient conditions, preventing condensation and promoting temperature uniformity. So the difference, as I say, you have 2 systems, as I said, air jacketed versus water jacketed, and as I said, we only do air jacket at PhD. Water jacket is very old technology. Instead of air, water is used, and around, as I said, 200 liters. So it's very heavy but stable, especially when there is an electric power shortage. You don't have a problem. Other parameters is the relative humidity. So the control parameters of relative humidity, we are using a water pan, which is actually a humidifying tray, so you can take it out easily and fill it easily. So the water pan can also be introduced in an autoclave if you want to decontaminate it or sterilize it. So it's stable and reliable, low cost, easy maintenance and cleaning, and it's an open water source. So there is no water level sensor required. Yeah. So have actually a multi-gas incubator. You also have nitrogen. So nitrogen can make the air very dry, so and causes slow recovery times. So they discovered at PHC a gas bubbling system, as you can see. So which is actually a small box where they bubble the nitrogen. There you can see in the picture, and through which it will cause more water to evaporate and get a faster recovery time of the relative humidity. So the green line, as you can see in the graph, is with the bubbling system, and the gray line is without the bubbling system, and you can see the differences of the recovery time. We have also vent motor. So the competition says that the vent motor is not needed because cells shake and is not good, but in reality the vent motor gives faster recovery time because it will spread humidity all over the incubator. So yeah. So a control of parameters, the CO2, O2, temperature, and relative humidity with a gentle upper airflow. So to have, we have for each parameter a sensor or control system, but for them all we have a fan. And to have all these parameters at the same level, all inside the incubator, we use actually a fan inside the incubator. So the gentle valve fan circulation and perforated shelves ensure even distribution of temperature, CO2, and humidity through the incubator. So this is also an advantage. So the fan, the circulating fan, the perforated shelves. So what the fan actually does is, as you can see on the picture in the right, is the fan pulls up the air up and then pushes the air down and over the water fan and then up. So the air circulation inside is always from the bottom and going up. So it's a forced circulation which provides improved airflow compared with natural convection methods, which can also depend on a stable difference between the chamber and ambient temperature. So we have now talked about how to get your cells growing in an optimal environment with stable control of parameters. Now we are moving to how to protect cell culture. So we have prevention and intervention. I will talk about some about the intervention technologies we have, and then we will go pass through intervention. So to protect your cells or cell culture, so actually almost all our competitors provide heat sterilization. Why? So if you have a contamination and something grows in your incubator, instead of a petri dish, which you don't want to happen, then you have to kill it using 70% ethanol. Or you can heat up everything inside the incubator, which is heat sterilization. We also have hydrogen peroxide decontamination. I will talk about all these technologies later on, but what we at PHC think is the better idea is to prevent it better before than to intervene if it's necessary. So we have actually 3 techniques for prevention of contamination, and this is how we do it. We have the HEPA filter, which is only a filter for the gas. So so some competitor actually also have the HEPA filter inside the incubator, but I just want to remind you, a HEPA filter just collects all the microorganisms. So it collects them and they will stay there, but it will not kill them. And the filter has to be changed every year, and if the customer forgets to do that, then they have a big problem. So we have a HEPA filter, we have IncuSafe and SafeCell UV, which is a UV lamp. I'm going now to talk about the UV lamp decontamination and SafeCell UV. So the UV lamp is actually situated in the air duct. So the UV will kill everything that is going through the air. So that comes with the air will burn. And actually, that is what UV light do. So when you're lying in the sun and you get some burns because your DNA structures are damaged, and that is actually what UV light. It burns or breaks down all DNA structures. So that means that UV light kills every DNA that it will encounter. So what we want is that UV light doesn't reach your cells because it will damage it. So that's why we have it is located in the air duct, which is shielded, so it will not pass through your cells. And all the air inside the incubator passes through the UV light. So after each door opening, the UV light will turn on automatically for 10 minutes after closing the door to kill everything. So again, so the HEPA filter traps while the UV light kills. So and the UV lamp has a long service, a long lifespan of 5,000 hours, which is about 7.5 years. But of course, it depends on how much you open the door. If you tell me if your customers tells you we are opening and closing the door 50 times an hour, so it also means that the UV lifespan will not be that long. And yes, another thing, so we have also that some say that the UV lamp will get ozone forming, which is not the case. If you look at the spectrum showed in this slide, you have the hatchet part where the ozone will be released. That's the red line, but our lamp doesn't shine at that weight. So the PHC lamp shines at 253.7, the purple one. And that's what we use to kill everything. And it shines at some other wavelengths, and that's what we can see. So if you see a blue lamp from the UV lights, you will see only this wavelength. So at this wavelength shines only when the incubator door is closed, so not when it's open. So after the incubator is not opened, sometimes, yeah, if the incubator is not opened after 12 hours, the UV lamp again switches on and will shine for 10 minutes to kill everything in the air and also in the water pan. So that means it continuously cleans the water pan and the air circulating in the incubator after you open and close the door. So here a picture for safety characteristics. So in the bottom of the chamber, UV radiation is shielded by the pan cover, and the cover can be opened and the pan water is disposable. So you can open it and pull it first. So that's safety characteristics of the SafeCell UV. So as I said, UV radiation is shielded with a duct and a pen cover, and here you have also another picture with a UV lamp without duct and pen cover. There are a lot of test methods done to show the effect on the chamber air. We have them. We can show them to you. You will get, actually, you will get this presentation, and I'm not going to go through all of them, but I will show you one, and this is where only done to convince the effectiveness of the SafeCell UV. SafeCell UV, the effect on the chamber air. So in this experiment, what they did is they opened the door for 30 minutes to contaminate artificially, and then they closed the door and radiated with UV for their 10-minute period, 0 to 5 minutes, and a sample of 200 liters of air, and then at the end they incubate the medium at 37 degrees for 48 hours and then counted the colonies. And if you can see that after UV radiation of 2 minutes, you already don't see any colonies, and after 5 minutes, there is also no colonies. So this is done to convince people that the cells will grow a lot, and that will grow, and a lot of tests has been done to show the effectiveness of the SafeCell UV. Again, we have a lot of materials to show the differences between the UV light and HEPA filter. This is a future note. We have it available, so if you want it, just use it. And also, a second thing, as a preventive method to protect your cell culture is IncuSafe. And IncuSafe states for copper enriched stainless steel alloy, which provides passive germicidal protection without rust or corrosion. So it fights off surface contamination as copper, but again, copper can corrode, and that's why we are using stainless steel. So it's a mix of both of them. So that's the advantage of stainless steel. So it does not corrode like solid copper surfaces, and that's why we have copper and stainless steel in our incubator. So actually, the whole inside of the incubator has IncuSafe. So actually the protection of this is again a test to show PHCBI's own copper enriched stainless steel alloy, which provides high disinfectant effect and prevents busting. So we have here an example with mycoplasma, which most of the cell culture research labs have problems with. So a positive control where you have the mycoplasma, conventional stimulants, you still have a contamination, and with the PHCBI IncuSafe, no contamination with the mycoplasma. Also with the copper, conventional copper, there is no contamination. So as I said, we have the IncuSafe, so copper enriched stainless steel to fight contamination, but not to have any corrosion. So what is actually the components that are from IncuSafe? So the whole interior, so the interior, the air duct, the vent cover, the humidifying pan cover, the perforated shelves, so actually everything inside. and test, tray contamination level test to test the effectiveness of IncuSafe and also IncuSafe germicidal interior. So there is a natural germicidal effect inhibiting the growth of mold, fungi, mycoplasma, and bacteria, as you can see. So this is about IncuSafe. Now another contamination is condensation. So which results in moisture where microorganisms actually can grow. So ideally you want to avoid condensation, and we are the only ones who have a dew stick to avoid it. So this is actually also a unique selling point. So how this works, so the dew stick has a Peltier element which has a cold and warm part. So the warm part sets it to ambient, is set to ambient temperature, but it is always 2 degrees lower than the temperature of the incubator. So if the incubator is 37 degrees, actually the dew stick will be 35 degrees Celsius. So automatically it's the coldest point at the incubator, which means that the water will condensate there and it drips the water in the water pan. So we actually have a little issue with the actual dew stick because it has a silver coating which corrodes and becomes black and it breaks down. It doesn't affect your cells though, but we are going to get a new stick from aluminum. So actually all our units have and will have a new coating. So this is about the dew stick. So we have talked about the safe cell UV, the UV light, the IncuSafe, and the dew stick. But one thing is also the user of the incubator has a very good effect on contaminating. So germs don't come like that. So you have to maintain your incubator, clean it. That means 70% ethanol, ethanol, and ethanol. So that's what you also have to say to your customers. So we have a good practice sheet. So how you can clean your incubator. You have to clean it off at least once a month, or ideally once every week. So we have also a cleaning manual. It's almost ready, so you will have this soon, where we show detail of how your customer can clean an incubator. And we have also some application notes talking about mitigation contamination in the interior. We have a lot of material which is all available in the product portal. This part was about preventing contamination. So, but if contamination happens, you have to intervene. And we have also some techniques to tackle that. So we have H2O2 decontamination, which is hydrogen peroxide. It's a 6% solution of hydrogen peroxide. Actually, hydrogen peroxide is very unstable. It's a very unstable molecule. So when you vapor it, the hydrogen peroxide breaks down into hydrogen peroxide radicals, and the hydroxyl radicals initiate a chain reaction of electrostealing. So it sticks to every DNA or every molecule it finds. So this unstable interval environment leads to death of all contaminants. So how it actually works, the steps. So do the preparation, which is you remove all interior components, position the interior components to specified location. It's all showed in the manual, and you set up the generator. You pour so the hydrogen peroxide is converted to vapor, and during this process the blower motor remains active, ensuring H2O2 vapor exits every point of the chamber. So and then you pour H2O2 reagents in the reagents, and after that you push the bottom H2O2. After a couple of seconds you will be asked, are you ready to start? And then you click yes, and after that you will be again asked, are you sure? Then you have to swipe, so you can't do it accidentally. So what happens then is that the incubator will warm up to 45 degrees Celsius, and the hydrogen peroxide is then converted to vapor. And if the contamination is done, the UV lamp switch on to resolve the HOO2 to water and oxygen. So it will break down the hydrogen peroxide to resolving it to water and oxygen gas. So you will have some water droplets at the end, so you just have to wipe them off. So this is how it happens, how you can see. So this is, you put the generator and pour H2O2 reagents, and then a vapor will be formed. Will warm up to 45 degrees Celsius. Vapor will be produced, and then the incubator will be completely filled with H2O2. Then the UV lamp will switch on for 90 minutes. Bring the H2O2, and there will be the remaining will be only water, and so there will be some water droplets on the bottom, and also a little bit of H2O2 residue, which you can wipe off. It doesn't harm you. I mean, if you go to the hairdresser, a hairdresser is more exposed to H2O2 than a general hairdresser, than this little bit of H2O2 that you will get in the incubator as a residue. So some safety measures, you have them, as I said. You will have the presentation, you can go to them. What I just want to point out here, so we have an electric door lock, which we are the only one except ESCO who have that. So that means that you cannot open the door during the H2O2 decontamination, same as in heat sterilization. Happen too. It is, which is safe for you, so you will not, you or your lab colleagues, they will not open the door accidentally. But it's also safe for your interior. So because if you open the door during the contamination, that means that the contamination is not complete and you have to start all over again. That's not what you want. So it's for both sides very useful. So our competitors, as I say, don't have it. So you can even open the door during heat sterilization. So I don't know. And we have here also some safety measures, the benefits of H2O2 decontamination, therefore, versus high temperature. So to sum up all these, the time, process time, it's way faster with H2O2 decontamination than with heat sterilization. So the process time of H2O2 takes under 60 minutes, while with 2.5 hours, while with heat sterilization hours takes around 11-12 hours, but the competitors heaters, it's around 12 to 14 hours. Also important to know, we have an independent evaluation from Public Health England to check if it works, the H2O2 decontamination, and you can see here the certificate. So what they actually said is that the PHCBI H2O2 decontamination cycle has been shown to be an effective method for deactivating Geobacillus stereophilus in each of the 3 test runs. So after exposure to the decontamination cycle, no growth was observed in the nutrient growth containing the coupons inoculated with the bacteria. So we have the certificate also. We have also a technical report which is also available, showing the advantages of the H2O2 decontamination, which are explained very well, and has 8 pages, and it's available also on our portal. So plus H2O2 decontamination, we have also dual heat sterilization. So we started actually with H2O2 a couple of years ago. We didn't have anything, simple reason because we didn't have any complaint from our competitors due to IncuSafe. Though a couple of years ago we started to have H2O2 decontamination, and now we have also dual heat sterilization. So the dual heat sterilization has 2 independent heaters, so 1 for heat sterilization and 1 heater for cell culture. So the reason why we use these 2 heaters, independent heaters, is 1 for power consumption, and also the second reason is that your cell culture heater will not get stressed and will be more stable. So if you will use it for both, and you will warm it up to 180 degrees, then it will get stressed. So what actually so we have the cell culture heater, and when you do dual heat sterilization, the second heater, so the heat sterilization will add up to the heater of cell culture. So we have also a better insulation melanin foam, as you can see, a thicker insulation. We have also a new frame construction which decreases heat leak from the door, and melanin foam has a way better insulation value. So the temperature outside the incubator will not be high, and this is very important. Why it is important? Because there is a IEC regulation from each CE marked instrument you buy. They say that the outside of the instrument is not allowed to reach above 65 degrees. So ours reaches 60 degrees Celsius outside, but though our competitors don't have that, so they reach higher temperatures, even till 100 degrees. You can't say that, though you can say to our customer that ours is under 65 degrees Celsius. So this is also a very important. So during dual heat sterilization method with our system, you don't need to remove the UV lamp, no inner parts. That means no sensor. You don't also need to remove the sensor or recalibrate them after the contamination cycle, which is the case at the competitors. So there is a quick rise of temperature, lower temperature distribution. So there is, as I say, no need to recalibrate temperature sensors or CO2 after dry heat sterilization. And yeah. Um, we have here a comparison of dual heat sterilization. We are comparing our MCO 170i AICD with the aerosol of Thermo. Here are the test data. So why we are showing this is according to the pharmacopoeia law, which depends on the country. Some use 160 Celsius to 170, ours is 180 Celsius degree. The degree it has to reach, it has to be 180 degrees at least a minimum of 2 hours during this decontamination cycle. As you can see in the graphs, ours is above 180 degree, a minimum of 2 hours. That the aerosol, I don't know if you can see the graph. It doesn't show clearly if it reaches 180, a minimum of 2 hours. So here is also showing the pros and cons of comparing H2O2 decontamination and dual heat sterilization. I'm not going to go through all this. You can see it, but what I want to point out is we are the only manufacturer to offer UV and H2O2 cycle, which takes only hours against heat. And so it's very no, but we also offer sterilization. Yes, important point which I already mentioned, but I want to point it out again. This is the electric door lock. It is an almost unique feature. Only ASCO has it, but we have it for the H2O2 decontamination and also dual heat sterilization. So as you can see in the picture, there is an incubator over there. They are just closing it with tape or just putting something on it, which any colleague who can come through can open the door. So we went through all the features for prevention and intervention. Now we are going to talk about the efficiency of use. So we have our integrated tray catches significantly minimize cleaning time and improves productivity. Why? Because we have less interior components. We reduced our interior components by 80%, which is very useful to know. Also, tray catches are integral part of this chamber, so which opens up more. So two incubators could have the same capacity in liters, but due to the configuration of the interior components, the capacity in regards to number of dishes and plastic could be different. And this is what we have to defend against competition. So our design is more efficient and smarter. LCD touchscreen, so it's very useful and very easy to use. You can set up all things. You can set up also a password. All the alarms can be managed on the screen, and the incubator stages easily from distance without interrupting your work. And you have a full color LCD touch panel that can be operated even with double glove hands, which is unique. We are the only one having that. So even when having your gloves and working at the lab, you don't have to put them on. So intuitive usability, everything is shown. Heating indicator. You can unlock the door. All the messages. So everything is shown. Also, an easy-to-use OLED alphanumeric keypad which allows convenient but secure user control. Internal CO2 interval. It has a USB port, power supply indication, and push button. USB port and security function. So as I said, parameters of the logged data, you can export them and have them if you want. And there are some security functions to protect valuable samples at the auto log, user ID, password, and the key lock. So the data login, example, CSV file, and yeah, the doors are reversible, so they can be doubles, and also you can put them left-hand door or right-hand door, depends. And the incubators can be stacked, double stacked for the 170 range, and also for the MCO 5 AC, they can be triple stacked. The location of the so stacked incubators and left-hand, which is very convenient for your customers if they don't have a lot of space. And yeah, troubleshooting on site. So PHCBI provides many tools for users to undertake own diagnosis. You can do audiovisual alarm functions, over temperature, temperature deviation can all be controlled. You have UV lamp, heaters, CO2 deviation, tamper-proof controls with a key lock, and access port for external sensors. So you can already do a lot. We are now going to move to the question part. I see some questions. Yeah, we have already replied to some of your questions. And as I said, we will also try to reply to them later on. Question from someone who is asking if the moisture accumulates on the zirconium sensor in normal CO2 only use, which could then cause cracking when O2 control required. So my colleague already replied yes. If you have a multi-gas incubator with O2 control, you cannot use it with CO2 only. So it can cause the zirconium sensor disk to crack. If the sensor disk is moist and then heats up to 200 degrees Celsius, it can heat up. So as I could see, a lot of the questions have already. Adding a sticker to the side of the incubators with storage advice regarding removing the relative humidity fan before turning the incubator off, so humidity will not accumulate on the sensors. To be honest, I did not understand your question very well. So if you can send us an email, I will be very grateful to answer it. So for the warranty time of the dual IR sensor is 5 years, like it always was. But the lifetime will be longer than 10 years, but this is for per unit. I will go to make a filter replacement, so we will at least 3 years. can hear all. They could hear because they have, it's not our problem. We already have questions and stuff, so I hope you could manage the problem.
I hope people can hear me. This is Jan speaking. We have some difficulties with the sound, and the problem is that most likely it's a problem we need to fix. So we will try to fix it before next week for the next session. The presentation will be uploaded in a PDF form on our product portal, so you can see the presentation back. I've tried to answer as many questions I could via the question and ask function. If you have any more questions, please don't hesitate to send us an email and we can answer them, or contact your area manager who will be able to help you out as well. Thank you all for this session and attending it, and we hope you will attend our next product training next week as well. Nessa, please, if you can, say something again to close up this meeting.
Thank you very much. All is said. So, as I said, if you still really have some questions, you can email to us, and hopefully we will see you next week. Thank you very much. Have a nice day. Thank you. Bye.